And we will start from the introduction. And we have 3 questions for the panelists. And we have time for the questions from the audiences. And we will summarize the 3D collection and construction in this session. Okay. Have you checked the white paper or question paper? So you can, if you haven't checked the white paper, so you can download the file from the website without password. So you can check the white paper. So then, this is a figure in the white paper, one of the figures. And we focus on the solving problems in the one field of indoor mapping and modeling and benefits. And we have many keywords like sensor devices or application modeling and navigation and visualization and applications and algorithm. So in this session, we focus on the data acquisition and the data modeling. Okay, next please. And now, this figure shows the sensing modeling. This figure shows that sensing and modeling are also included for the indoor mapping. So we have many tools for the 3D modeling and data acquisition. For example, we can use a calculator to present a 3D space or actual space. And we have to get the 3D data, like images or point cloud to model the 3D space. And we can construct moving objects and changing objects. Okay, next slide, please. So this one is an example of the point cloud application. So this is a Japanese size of house, and they use fields. GRK possible. So we have acquired a point cloud in Hokkaido in Japan. So this is the upside down is a directional visualization result. And then we can reconstruct the 3D surfaces or 3D polygon. And in this experiment, I reconstructed 3D surfaces based on the point-based render. So we can reconstruct the point cloud or the images or videos. Next slide, please. What you see here is Bunkanjima Island. This is famous for the movie. So have you checked 007 Skyfall? So I have checked the 007 Skyfall in a long flight from Tokyo. So, yeah. And this place is location area, so the 007 Skyfall. So, okay, create the picture. So we have 3D data point cloud. Yeah. And the field covered with tracer data scan. So usually we cannot answer this area, but if we have a chance to get the 3D data, we can share the 3D information with the general users. Okay. They can put it somewhere on the left of the account. Okay, this figure shows, this figure is one of the figures in the white paper. So we focus on the various points, like visual sensors and data structures and modeling and visualization, navigation applications, and data issues and assembly. So today, we will focus on the application and sensors and the data structures and the modeling. Okay, next please. Then, in application and sensors, we have many issues like variable lighting conditions, variable accuracy, automated visual removal, sensor fusion, and mobility, real-time application of dynamic environments, learning the composition of the space. And in data structures and modeling, we have many issues such as software tools, diversity of the indoor environments, real-time modeling, and dynamic abstraction, discovering the context of the space, and integration with GIS, fitting information modeling. And today we had three questions right here. First one is the best device for the data acquisition, and the second one is real-time processing application, and the third one is the best data collector and model. Okay, let's start the discussion. Next, please. So the first question is the best device for the data acquisition. So in indoor environment, we have to get 3D data without GNSS. So, but we have many sensors on the system, 3D system, 3D data acquisition systems, like camera and the scanner and the mobile scanner. For example, in camera, we can provide photogrammetry and the structure for motion. So these techniques has an advantage such as cost, low cost, and high speed. And it's because manual identity works or structure for motion cannot reconstruct moving objects. Okay. And then we can use laser scanner, tracer laser scanner with registration. So we can use a tracing laser and connect or time of flight images. So the advantages are there are many advantages such as speed, high speed data acquisition, but the sensor cost is very expensive. This is the problem. And we can use a mobile scanner. A mobile scanner means a line scanner and a combination of the line scanner and high view. So we can get data for point cloud in high speed. But this system is also an expensive system. So now we have various sensors or systems to get the 3D data. So what is the best device for the indoor data acquisition? This is the first question. Okay. Next, please. So now we have comments for panelists. Okay. To ask some please. Very fast.
So my answer is closely related to what I presented this morning. It's a combination of knowledge plus interfaces, because I think this is an interesting option because it's on the one hand low cost and it doesn't depend on infrastructure. So what do I mean with knowledge? Knowledge can stem from either already existing indoor geometries, as I showed this morning, but knowledge can also stem from the outdoor. So Masafumi showed the slide with the different LEDs. Nowadays, we have already very good solutions for the reconstruction of the building shell. So let it be LED 1, LED 2, or LED 3. Even for the reconstruction of LED 3, solutions are currently being integrated into commercial projects. And these LED 3 building models and also the construction process to create them contains structural knowledge. And why shouldn't we use that? This structural knowledge can be integrated either directly by means of geometric constraints or in an abstract form, for example, by means of a grammar or by any other knowledge-based technique. Considering the traces, well, this is what we use. It's only an option. And it's also only 2D. The third dimension comes from the information from the exterior model. Of course, any other additional device would be helpful to increase the detail level and also to let our indoor model faster conjugate. In our institute, we also used additional devices, for example, the Kinect, and we used it to fit the prime clouds derived in some rooms of our institute into the course building model, which were derived from the photograph floor plan, as I explained this morning, which is the work of my colleague. So to sum as I said, it's an interesting option to have something low cost, but of course we need knowledge to support the reconstruction out of such data.
Thank you. And about that,
So I think it depends on the budget that the people have for the task that they want, for which they want the 3D model. Do they want a model that is fully intelligent or is just visual so that it's used for navigation, for example? So I think that the first thing is to determine what is the task that you want to do, the budget, the accuracy that is required. And then from that, to decide what kind of technology that you use for building your model. I would say that in general, in looking at the advancing of the technology today, I think laser scanners are becoming extremely popular because they are more and more cost effective. But so if you want to measure stuff, then the point cloud is appropriate because it gives you the 3D model with the XYZ points. For doing feature extraction, the point cloud are really great because you can recognize some elements from the point cloud. But for visual aspect, the point cloud often lacks in crispness. So photographs will help improve the visual aspect. So I think for if you have some need for accuracy, measurement, and good visual aspect, I think a combination of point cloud and photos is very good. If it's only for navigation, then maybe just photos is sufficient. Maybe we talked about landmark this morning. In the photos you have those landmarks, so the panoramic photos could be useful with maybe some punctual point cloud now and then. I was giving another example for maintenance and operation purposes, just to guide someone and so that he see the context of what he has to maintain, like a valve, for example. Then maybe just panoramic photos would be sufficient. So the essence of my answer is mostly laser scanning and panoramic photos, but you use professional or less professional too, depending on what your budget is in your task.
Thank you. Okay, I have a comment from the Martin. Like I said, 3D scanner and the potential lightweight light. Okay. Sandra?
Yeah.
Okay.
Yeah.
Please explain about your response to this question. Please.
Yeah. Okay. Yeah, when I saw this question, I also the first question. Okay, what is the task? So as this was not specified, I thought, okay, let's produce an answer that's or let's give a data set that can answer most of the tasks. Yeah, I think threshold laser scan systems nowadays are the systems that can produce high quality point clouds. But I also said, okay, maybe in the future threshold system may be a bit too expensive and it's too much hassle to capture the data. So in the near future, I think mobile devices will increase, will produce better point clouds, but nowadays the registration of those point clouds is still a problem to get good point clouds. And yes, some of you may know the ITC building here in Enschede. But when I look at this building and when I saw this presentation on the grammars this morning. I thought, okay, how can we adapt yeah, the general knowledge on yeah, dividing spaces into rectangles or yeah, perpendicular walls, etc. That's not really possible in the ITC building, so still I think the data as such, the raw data is important for indoor mapping.
So mention that in the current state, we can use telescope laser scanner is the best one. And after next year, to 2014, wearable devices is best one, right?
Yeah.
Okay. We have a discussion time later, so let's move on to the next question. Okay. So the second question is real-time processing. Usually we say that real-time processing is required, important, significant. But what is a good application for with real-time processing? So now we know that some applications like building information brain, location-based services, and autonomous robots or something like that. And we have many things for this real-time processing, like public space or workspace or private space. And we want to reconstruct many objects like wall, door, ceiling, window, walker, and signboard, goods, and many things. So what is interested in real-time processing applications? So, and we have comments from the panelists. Okay, please explain the information.
So at our institute, considering the indoor applications, the interest is in supporting location-based services. And in my opinion, the best support is having up-to-date indoor models. And this is of course very much related to real-time acquisition and modeling of dynamic environments. We are here at the beginning. We are just concentrating at the moment at the working space, just because we have access to offices. But of course we would like to have approaches also for public buildings in general. What we aim at is, in my opinion, what is aimable is to have a representation of any 3D objects which support location-based services. This can be either fixed objects like windows, walls, doors, but also movable objects. Such movable objects can be, in a positive sense, helpful to navigate or to orient oneself, but in a negative sense, they just are obstacles for blind or disabled people. And especially when we are interested in application scenarios like navigation for blind people, then it is very much desirable to have an up-to-date indoor model. That means that we have indoor geometries which not stay fixed after being created once, but which instead are continuously checked against new observation data, which are gathered from users, maybe who are just navigating in this office or in the building. So, navigation for disabled or blind people, in my opinion, really requires up-to-date building models, and this is an application scenario which is of importance, I think.
Okay, thank you. Please.
So when I was reading the question, I was wondering what needs immediate processing, something that has to be really, really quick. And the first example that came to my mind is we have many more. We have I've shown many applications this morning that uses augmented reality, where you take what maybe your tablet views to the camera, your reality, and then merge your 3D model with this reality. Now, there are many problems that have to be solved instantaneously, especially if you assume that the person with the tablet is moving around and is looking at different places. Then it has to be very, very quick. So, for example, you need to have the location of the tablet first. Today, with GPS, with the latency of 3-4 seconds, it's not working. It's not pleasant. So it has to be faster than that. So if we think about indoor, we will have to have something that is instantaneous in terms of location service. Same for the compass and the inertial system that analyze, how you move. It has to be also instantaneous. And then to help the registration process, what we often do is we try to recognize features from the camera feed so that we can fit things that we recognize from the 3D model and do final adjustment. So these recognition of features from the camera feed has to be instantaneous. So that's an example. And I've shown that augmented reality can be used in many cases. In construction, for example, it could be in monitoring the progress of the construction. Here, I thought about another example. When there are last-minute changes, you have the field worker that is there, he has a problem, and he needs often the advice of maybe the engineer who is in the office. So he has to share the problem quickly. So having a collaboration application that allows maybe to use the video feed and send that to the person in the office so that he can react, adjust some design, give some new measurement, and give advice. That's also nice.
Thank you. And I have a comment from Martin. Texture of the spaces and 3D objects, and they are smart things. Okay, Sandra.
Yeah.
Please, could you explain about this answer?
Yeah. Yes. So again, I was a bit struggling with finding the answer because the question again was a bit open, but that's okay. But I think during evaluations, it is necessary to find the correct route, for example, to the nearest emergency exit, and then it would be helpful if you could have real-time application that can detect obstacles that were not there half an hour ago, 1 hour ago, a few minutes ago, but it is obstructed now, so you need to find another route in case of emergencies. And there I really felt the need for real-time processing of mobile devices, UAVs, maybe tablets, things like this. So, but I agree with the applications of LM. During the construction, it's also necessary to monitor whether the construction at the time of building something is correct or at the correct place. Yeah, that was my answer. Yeah.
Thank you, Sandra. Okay, let's go to the next question. Next question. Let's tell the question. Okay, yeah. Now we have many tools or applications to get a 3D data or to generate a 3D model. Then, who is the best collector, or who is the best data collector or model? Now we have three kinds of users or editors. The first one is a professional like us. We have many sensors, high-spec sensors to get 3D data, but in a sense, in the field is larger than part of Elberink. So we have to prepare many steps to get 3D data. And the second users second keyword is crowdsourcing. So do you know the OpenStreetMap? I believe that you know the OpenStreetMap. So OpenStreetMap is an open mapping project based on the open source. So we can provide some tools or software, freeware for the general users. For example, we can get GPS receivers and we can get remote sensing images to generate maps with polygons. So we have many resources, but the problem is reliability. And the third keyword is full automation. We can achieve high-speed processing or high accurate data generation, but the integrity is one of the problems. So we have to develop some good software to improve the algorithm. So the third question is that who is the best data collector algorithm? So we have a plans from for this. The next slide. Okay, let's start.
I would like to set the focus on the crowd, because the crowd is capturing data continuously, either actively or passively. And this is an enormous resource which should be exploited. Of course, you mentioned the limited reliability. This is not also because people are non-professionals. This is also because they are using low-cost devices, or acquisition configurations are not perfect. The acquisition is rather randomly instead of straightforward, and some areas are more popular than others, so we will have different frequencies of observations. But however, we can compensate for this limited reliability. And therefore we have different possibilities. First, the crowd can model themselves, but they don't have to. We can also say, just let's use their data, which is acquired by them, and apply automatic modeling steps or techniques. And second, which is related to the first one, we can make this reconstruction more robust by introducing knowledge about the objects which are to be reconstructed. This can be again grammars or any other form of knowledge representation. And this would strengthen not only the reliability, but also the integrity, because here we can start such kind of acquisition and enhancement. So we have 3D geometry which is continuously improved by continuously using new data from the crowd.
So I agree with you that there are certainly many applications where crowdsourcing apply. I would say it's maybe more when it's less specialized. You don't necessarily have to provide training to the people. It's maybe not the same accuracy that is required. And OpenStreetMap is a very good example of a successful experience. So for mapping indoors, public indoor spaces, crowdsourcing could eventually be a good solution if we provide software that is easy to use and that there's some rigorous aspect in behind that can be achieved. However, there are cases where if you build a $60 million building, I can guarantee that the people will want to have professional equipment, professional people, and everything that will guarantee the success of that project and the precision that is required. And that's a market in which Nakagawa has been, of course, working for many years. So, I mean, of course, we're doing our best to provide the best solution. So I would say we have the best solution, but there's competition and there's other people that are also very talented in creating software. So I guess it's a selection of the user for the best tool. I'm in that position. Suggest the best.
And I have comments from the Martin. Today, professional users, and in the future, algorithms are augmented by professional users. Okay. So Sandra, please.
Yeah, it depends on whether the user needs are clear or not. And yeah, I think it's a kind of interaction between the users. They have to define what they want. They have to define their application, and an interaction between the user and the producers of software or the scientists who provide them with the tools to be able to let them produce their research by themselves. I think nowadays the user knows more what they want than the scientist, so why not give the user the tools to produce the data and give them some input data. The question is whether they should collect the data by themselves or they should hire an experienced data collector. That's also an interaction between the user and the producer of data and software. But if the users, if the requirements are very clear, then it's up to the software developer to produce tools that exactly fulfills those requirements. That's it from my side.
Hello. No, I mean, I'm thinking it's time shift. So just to introduce myself, I'm coming from a Center for IT and Architecture, which is based in architecture, obviously, and we are part of a bigger European research project which is called DuraArch. And one of the points in there is like to look, okay, how do we link the information models that architects and engineers and the whole community, which is linked to that part, are using those information models, which are usually called BIM or so. How do we link this to other information, mainly their point cloud and 3D scans, so like the growth of what geometricists usually is doing. And so when it comes to the effect of who's actually acquiring the data, then we see here with our stakeholders in the Scandinavian context a very interesting part where actually the stakeholders are going more and more out and collecting their own data. So as 3D scanning becomes very scalable and relatively cheap, so people see the benefit of actually buying those things, or architects are buying them, and then they're producing their own data. So what I'm speaking here of is not the world of, say, I want to have data for Google Maps or things like that, but I want to have data on a professional basis where I can start my building practice or my decision making for investments or for my facility management into it. And so that there we have this interesting situation that people are actually collecting them and they actually really know well what they want to get out of the data. So which level of precision they want, what are the features they are looking for, but they are in a situation where they are not able at the moment to actually extract those data. So which is then maybe the next point of our discussion. So I think the best field are at the moment the users themselves, because they know actually what they want. They are just not enabled to get those the information they want out of the data which is point cloud. So that's something where we are, for instance, working on finding algorithms that then can work in the different phases of a building project and then provide the right information, because it's also very different level of details they want to work with, and different level of precision they are working with. And it would be interesting to also hear, as now an alien to the world of geometrical, the conference that you're in South Africa, like, okay, what are the other approaches, or what is the thinking in that field? And it's like, how do professional users get actually the right data out of it? And one of the points what we are seeing here is that, for instance, people like typical, are you still hearing me? So what we are seeing here in Denmark is that typically land surveyors are the ones who are giving to our professions, so architects and engineers, and also like building companies, they are giving the kind of the data, but we see that the architects and engineers, they're not able to use this data anymore directly, because they are like, they want to have 3D data, they want to have the richness of the environment, and they are scanning, and they're not getting this from the land surveyors, because the land surveyors are not understanding how a BIM model works, or how what the user actually wants to have at this specific moment of time. So in the beginning of the building process, or for later refinement. That's a situation that we are finding here. We have just conducted this study on the topic. Yeah.
And Martin, thank you for your comments, your email. Thank you. Okay, we have 10 minutes for discussion after this training. So next slide. So now we had 3 questions for the panelists speakers. So are there any questions to the panelists or speakers? So I know that we have many questions in the this one.
I guess about the first question, the device for data acquisition, I have another opinion. Maybe not only the photo, not only the scanning, but maybe the video more important, because a lot of the indoor environment we have already the video monitor system, so we can use such kind of the video data for the change regime for where some living room. So maybe this is a more important data source for the indoor environment. Another one about the surveying robot. That's it. Even for the construction of the engineering project, like the mining work, like the tunnels. So because in such kind of the environment, we cannot use the laser scanning system for dynamic verification, because the satellite system cannot provide us any information. You have to set the control point. It's difficult for the moving and of the device. So maybe we need some kind of the I say there is a automatic system for the mirror. Like we can use some new kind of the image system, like the distance reading, like this. Not only the laser scanning, that's it. So that's it.
Okay, you mentioned that the video is important devices for the indoor mapping. So do you have an answer from the Allen or Suzanne or Sandra or Martin?
Yeah, I mean, there are definitely applications where it also makes sense.
But the point is, is it is for construction or wind navigation? Because all kind of sensors, but they can be used for different purposes. Okay, we did also invent some experiments with ultrasonic sensors, but it was pure for organization, not that much for collecting data and trying to reconstruct it to the model. question is a little bit also which sensors are appropriate to treat data destruction and which sensors are more appropriate for using them is straightforward for validation.
So do you have any comments from that?
I think if we look at it in very much in South Africa, we try and classify navigational GIS and survey grade. Once you captured survey grade, you can always degrade the data to the GIS level, but the other way around it is not possible. So that's one of the big issues at the level that you capture is, as you say, where do you want to use the data? And but then one of the other major factors about these sensors is how do you archive and capture and basically pack the data away, and at what point do you archive what data? Meaning, do we archive raw, first generation processed, final generation processed? Right. So there's a lot of these issues, and each of these sensors have got a different knock-on effect on your strategy how to cope with it. A lot of this, and especially when you talk to construction and where Bentley is coming from, that environment, built environment, a lot of the decisions to spend money on high-end systems is not based on the survey value, but it's based on the risk value of the projects. If you look at most of these things, projects get out of hand because of budgets, because people didn't design for things to be there, and they are there, and therefore you have to alter the designs. So all that plays right into the hands of what type of technology you're going to use and what strategy. I think there's a middle group in there, which I call the poor man's mobile, which is a stop-and-go terrestrial type of systems. We often in South Africa, because we haven't got that amount of money in the practices here, have that guys want to use a sensor in multiple modes. For example, to take a terrestrial scanner, his decision will be, I'm going to buy a terrestrial scanner because I can lock it in 2D mode and it can be used on a mobile platform as well. So multi-use of the sensors also come into play around your strategy, what technology you're going to use. But as I say, the forgotten child is the stop and go method. Our biggest problem, like in the early days when we used GPS, just for a moment to put us compare technology progression, we had static, and then for a very short period of time, and I think a few of the professionals in the room might remember it, we had stop and go, but then we got real time, and we absolutely went past that. When we look into our world, the scanning world, we are going to, it's probably worth stopping in that middle position because of the cost implications going from terrestrial to mobile. And then also the complexity of processing data in mobile to get to survey grade is a world of its own. So there's a lot of those things. Into the factors come military grade IMUs, and I know there's a lot of software strategies that come into play to bring the cost of the sensors down. What I'm saying in that is that sometimes instead of throwing more money at hardware, we throw more money at knowledge and smarter ways of handling the data that come out of sensors. So, and what I've been saying, there's a lot of different strategies, a lot of looking at where do you want to fit the data into, and therefore decide what sensor is the best for your application. And the worst thing that you can do is to try and force a hardware or a sensor where it doesn't belong. That's in the practical, theoretical side of pride on the ground.
Okay, anything to add to this topic? Okay. Ready?
Sorry? Yeah, I've got a question to Sandra. Hello? Can you hear me? Okay. So I've got a question to Sandra. In the slides that we were asked to prepare, you said, okay, the biggest challenge for the future that you see is the question of semantics and how. So what I would like to ask you that if you're considering semantics, so on which level of granularity, of which information level are you thinking those? And then the second one is like, what is the framework in which you would disseminate the semantics? So if you find the semantics, or is it then something that you would give to other models which are around, or is it something which you, like how do you communicate that you found the semantics within the model and then tell it to models of other people who are working with you? Did it become clear?
Any comments?
I think it was a question to Susanna.
Susanna, yeah.
Okay, I would refer to my comment on the summary slide, I guess. And there I said one of the biggest challenges in future, I think, is semantic interpretation. I didn't have in mind a specific scenario. It was just to make the contrast clear that at the moment we have such a lot of devices and acquisition methods or processing methods which deliver dense point clouds, but all of them are uninterpreted. And we have good solutions, also current research, but still we have good solutions to make geometric interpretations, which means fitting shapes or planes into these point clouds. But it's already very difficult to get topologically correct models out of these different shape hatches. And what is even more difficult is semantic interpretation, so what's the meaning of these different forms or shapes. And in indoor applications, I would say, first of all, we should know which is or what geometry is a wall, what is a door, in order to have or to run navigation applications or to support them. And of course, even further semantic interpretation would be helpful, like the functionality of rooms, or which office assistant or which member is sitting in this room, is there a meeting at the moment, stuff like that. But I didn't have in mind a specific scenario.
Yeah. But this question links very well to what Francois just said. Multiple sensors to make the data collection efficient. Do you think if we combine several different sensors during the scanning on a kind of mobile platform, this will really improve the knowledge that we will get from the information that we can extract from our data?
I think flexible systems which then can build together and to match my specific task. This is what we need.
So I have another idea. The sensory data is not the most important data source for the indoor modeling. Only for the surface, for the geometry. For the semantics, maybe the beam or the CAD data is more important. And the sensory data just used for the change station. For the environment change, we can detect it. Because for the model, most of the building we have already the CAD data, the document like this. This is most important data source we have to use. So there is also that problem, how to integrate the beam or CAD data for the indoor modeling. I think this is important for semantics information collection. From sensory data, it's difficult to collect the semantics, the function, the physical, the behavioral, I think, from sensory data.
I didn't really hear the last about the multiple sensors. That's completely right. That semantics are probably not the one sensor, but it's a combination of different ones. And so one thing that I don't know whether there's research ongoing in UPIP, but would be interesting to know is like in 3D scanners today you get a lot of nice imagery. It's for free, so every flower scanner or Leica or so that do images if you want as well as this. And so like, we see like a big potential in And the combination of like image detection, threat digital computation, and 3D point cloud scanning, I wonder whether there is some work ongoing on this field.
You have no somewhere?
Well, I heard something, but I did not get a question actually.
May I ask one question?
From me, I guess, huh?
But unfortunately, we don't have the time to. I have to close this discussion. So, next slide, please. Okay, let us summarize this public discussion. So we have no time, but we have 3 minutes. Okay, I have comments on summary from the panelists or speakers from Stan, Elberink, Martin, and Sandra. Okay, please summarize the presentation.
Already commenting on this point, the thing is, biggest challenge semantic interpretation, and as somebody from the audience mentioned, the integration of different roles, because it's not necessary that we interpret semantic from the scratch if it's already available. So we have to find a good combination.
I think we already accumulate lots of data that we collect, and we have lots of users that even today say, you know, our organization have invested a lot in acquiring all this data, but we can't use it because it's not processed properly, or they cannot visualize it as quickly as they want. So I think, and it's going to augment exponentially as we have more use cases where you want to scan every day in construction, for example, to show the progress. So as we have more and more point cloud images, videos, and all kind of data coming from different sensors, I think we need to focus on an approach where it can be automatically processed, you know, by, you know, we conduct experiment in the cloud currently, for example, where we upload lots of point cloud in the cloud, so don't get confused, point cloud, and we have tried to leverage ways of processing in parallel as much as we can, like extracting the terrain, extracting cable, extracting, you know, the features from the point cloud. And because it's computing intensive, in the cloud we can launch many computers, you know, in parallel, 50, 100 of them, and then do the task much faster. So we've been experimenting, maybe you're familiar with Oude, that was initially, that come from Google, that you know, that's a technique that they use for browsing all the websites of the planet. And they offered their knowledge to the open source community, which came Oude. And Oude allowed to do, you know, parallel processing on multiple computers, distributed computers. And we're looking to that to see how we can automate the process as much as possible. So in a world where you could scan data, upload it, process, and use it as quickly as possible.
Thank you. And Martin, please. Could you summarize your opinion?
Okay, yeah, thank you. So I wrote as well like semantics as Susanne did as well, and I hope you can all hear me. And so what I see also the challenge is how do you integrate those point cloud scans, so the capturing of the moment into a data lifecycle. So how do we get a comprehensive understanding of the data that we have, and how do we then create the semantics between the different steps we are doing? So where we are entering now, like in a world where, for instance, in the building profession, data is no longer seen as just from design to build and then we forget it, but it's about like the cyclical movement through different layers of data which are coming from a different granularity, different levels, but also from different times. So how do we navigate it, and how do we create semantics between them, which can then inform like other systems? And now I think that there is a lot of need for research, especially on kind of creating automated systems which can handle this huge amount of data that we are having and we are getting, because it's really a lot, and just running through some point clouds in parallel, as my predecessor said, is like a huge task. So yeah, so semantics and comprehensiveness, that's my thing. And thank you. We are, so I have to promote like our research project, which I just do here with DuraArc, and I hope to be part in future conferences of yours in person, so that this lack of time doesn't exist here. Thank you.
Okay, thank you. Alexander, please summarize your opinion.
Yeah. So I just added my biggest challenge on the chat of this presentation, but I think the first challenge is to get a fast and accurate point cloud from mobile devices. Nowadays the problem is still in the registration of those individual point clouds. So the first task is to connect them together, or at least for our department, that's the biggest challenge for 2014. Then after you have this point cloud, you can start the object detection or the modeling or the change detection. So yeah, for me that's the biggest challenge, the registration of individual point clouds.
Okay, thank you. So the time is coming. So our panel discussion was finished this time. So in closing, I'd like to thank the speakers, the panelists for their contributions, and also thank audience for the many sessional and commensal messages. Thank you very much. And Sandra and Martin, thank you.
Okay.
Okay.